our main focus is on the database design and implementation. So that is actually the easier part of the database, the subject. The second part, the rest of the semester, we will talk about the database, the algorithm, and more focusing on the DBMS itself. So which means think about you are not going to design and implement the database application, but you are going to develop the database itself, like the Oracle, Informix, and DB2. So to develop such a DBMS system, we need to know what is the data structure, how they are organized, what kind of algorithm are used. So your second project, do you remember what is the topic of the second project? It's a index organized table. It's a specialized table structure. Their organization is not following the traditional database structure that we are going to discuss today and the next week. Instead, it borrowed the data structure of index. Okay, it's kind of the combination, hybrid of the index and the table, for example. So from now on, we will talk about such a data structure, index structure, and the database algorithm, including query optimizer, query processing, as well as the transaction management. So that is our main topic. So first, in this chapter, I think the chapter number may be different depending on the edition. So, but you can find the disk storage, basic file structure, and hashing. So that means, when do you remember when you join the computer science major, so you probably take the very basic level of the introduction of the computer science subject that include programming. So what is the computer and what is the computer science? Then you implement a simple algorithm using the Java program or C or C++ program. Also, at the same time, while in your sophomore, you learned about data structure. Data structure is one of the most important class subject in computer science. So that is a reason. So actually, the introduction of the computer science or computing or the problem solving is for the data structure, of course. So to understand the data structure, we should be able to implement such a data structure. What kind of data structure did you learn? So sorting is one of them, and also linked list, the heap, queue, and what else? The tree structure. These are the basic data structure. Why do we need such a data structure? What is the main topic of computer science? We are dealing with the electricity or the material or mechanic? No, we are dealing with the information, especially using what? Computer. So computer cannot understand what I'm saying or my feeling. So my feeling also information about the professorly, and your facial expression can be the information about yourself, but it cannot be managed by computer. So to manage such a computer, we need to digitize 0 or 1 data structure. To do that, we learned about such a different well-known data structure. Okay. So, what is our topic in this class? We are dealing with also data, but especially very large data. When we have the small amount of data, like the integer 1 to 3, we don't have to use a database system, right? Instead, we can use file system. Even we don't need the file structure. Memory is enough, right? So when you create the program, so you need the source code, right? You need to code. In your code, you can define integer I, then I is the 1 to 3. Or integer I, integer j, integer f, and assign the 1 to 3. That is the exactly same as what we are doing. Okay. However, that is very simple, so we can use just a variable memory structure. When we have the relatively large data, we need to use a file system. Okay, like the list of students. It's tedious job whenever I create and modify whenever I have a new student, I need to modify my program code and compile again. So it's not convenient. So we need a file system. Even file system, if I add a new column, like I need to manage the project C information. Do I need to change it? Yes, I need to change everything. Because of that, we need database. So that is the main purpose of the database. So eventually, our data should be stored at somewhere our computer. So what is this? It's a computer. It's a server. It has the CPU and memory, okay, and a lot of devices, and they are connected through the bus. Okay. Also, we have internal hard disk drive and also external hard disk drive. Okay. It's the main architecture of our computer. Okay. If you are using just the program memory-based data management, we need only the memory and execute the program, executable file. You can run your program that will be processed in your memory. You can manage integer I, integer j. If you are using the file to manage the list of students, you can store such a data as a file. At that time, what is the format of this file? What is this file? This is the text. It can be text file, it can be Word file, it can be a Microsoft Excel file, any type of file it can be. Which means it's a file on your file system. Okay? Sometimes you can use the file structure provided by your file system. Do you remember your operating system class in your operating system class? So you learned about the file system. What is a file system in your operating system class?
Data structure.
Data structure. And for what? Manage files, okay? And directories, okay? It's a software also. So in your file system, you provide the file data structure. File data structure has, just like the other data structure you learned in your data structure, CS102, what are your data structure course, whatever the course number is. So you need 4 basic operations, okay? What are they? Read means a fetch, update, delete, insert. So it's exactly the same thing. So when you are using the file on your file system, it can be a text file. It doesn't have to be only TXT file. That's the only one example. You can use Microsoft Excel. Who design the data structure of the Microsoft Excel? Microsoft Excel application define the data structure, so you can follow their data structure, then store the data using their application, right? TXT file is the same thing. It's so simple, so you can directly open the file and the updater. You can do the full basic operation. You can do the same thing. So when you are using the files, so you should know such a file information. So what about the database? So database, when first time the database was developed, the DBMS system developed, they need the exactly same data structure, the storage file. That is the disk storage and file structure used by what? DBMS, like the Oracle, Informix, DB2, they need to use. The first time when they develop the DBMS system, they do not have their own file data structure, okay? Instead, they try to use the existing file system, file data structure. For example, TXT file, they can use, or some other file structure. They can DB file or the other the data structure they can use. Instead, why don't we define our data structure storage? Okay, then more convenient and efficient to use. So that is the topic of this one. In other words, if we develop the new DBMS system, okay, actually as I introduced, we did before. So first we need to design the database model. What kind of model we are going to use in our DBMS system? For example, UBDB, the DBMS system. Let me show you.
Professor, one question.
Yes.
Is this storage the same as this scheduler?
Hold on. Let me search first, then repeat there. Right here. This is actually the DBMS that we developed in this class several years ago. Yes.
Is this storage the same as this scheduler?
Which scheduler?
Yes. I mean, is this storage the same as this scheduler?
No, this is a different data structure. So that we are going to discuss today. Okay. So for example, when we developed such a DBMS, it's a very simple relational database management system we developed. We need to decide what kind of file structure we are going to use. Whether we are going to use a TXT file or whether we are going to use a hash file, whether we are going to use our own data structure. At this time we use the TXT file, okay, as a file storage. So where we can store the data, that is the main topic of this chapter 16. After that, database has, why do we need to use the database? We need to access the data very fast, especially when we have very large data. However, as we discussed a lot, file systems sometimes are faster than the DBMS. Why? Because DBMS need a lot of overhead. You need to manage the memory, you need to manage the many processes. It takes a longer time. So how can we speed up? One of the ways is indexing, just like the index in your textbook. So index is another data structure. So followed by after we discuss about the file structure used in DBMS, okay? Used in DBMS, then we will discuss about the indexing structure. Then in your project, after you understand the file structure and indexing structure, you should be able to implement something new. Data structure used in the database management system. One of them is the index organized table. That is the project B topic. Okay? So it's a table, but it uses the indexing, the data structure for the storage. That's just the idea. So this is what we are going to do. So these are the basic the data structure that the DBMS, database management system, use for their storage. What about the Oracle? Oracle uses such a data structure? Not that simple. Oracle has their own data structure. Informix has their own data structure, which means if I copy the Oracle, the database file to the Informix, no, Informix cannot read. Okay? What are they? That is actually, do you remember this diagram? Three schema architecture. So conceptual schema and external schema, this is what? Internal schema. Do you remember that? It's a three schema architecture. We have been focusing on mainly conceptual schema to design, okay, database. And little bit about the external schema, such as view. Using view, we can do the external schema. What about this one? Who is in charge of that? Internal schema. database management system, Oracle information, we don't have to worry about. As a user, we don't have to worry about what's inside. But this, from now on, topic of the rest of the topic focus on this internal schema. Internally, how the data is stored, how the data structure are organized. Because of that, some of the students are confusing because many of the students think about the database course, database design. It's only for the conceptual schema design. Yes, it's true when you join the project after graduation, you don't have to worry about how the data is stored. Instead, you should be able to implement the SQL and the database application. However, when you encounter problem of my query is perfect, but it takes longer time than I expect. I don't know why. Okay, why? Because of the lack of knowledge internally how they are organized. Okay? And whether there exists something locking problem or transaction control or indexing problem. So from now on, this part is also important for the general database user, like including the database developer, database architecture. Okay, not only for Oracle employee, Informix employee, no, it's very important for the also database developers. Okay. So these are the topics that we are going to discuss today. As it's not the complete the list. Actually, these are the basic. And in real life system, such as Oracle Informix MySQL, they use their own. Based on this one, they use their own data structure, complete the data structure. Okay. Many of the topics are conflict with the same thing that you learn in operating system class. Why? Because the first time when we developed the database management system, we borrow the idea data structure of used in the operating system, just like the application. Think about when you develop the editor, the text editor. Okay, first time you do not have your own format, okay, structure. Instead, you can use the TXT, plain text file as your file. Then, if you need like the graphical user interface or other functionality, you can change it. You can make your own data structure. So, similarly, the database, the storage part is the first time, or the basic idea are the same as the one in operating system. So if you already took or if you are taking the operating system class, it's quite similar, almost the same. Okay. So anyway, the database storage are in the disk. You should know about the hard disk drive, the hard disk drive data structure. Okay, so these are the overview of the HDD. So we have the cylinder, we have the spindler, and these are the rotating, and this column is moving forward and backward, and then finally we can read the data from a sector. Then your database information, database file are stored in this surface of the magnetic, the disk. Okay, it's the same as the operating system. Operating system use the same the data structure and the mechanism. Okay. However, nowadays in operating system, is there anyone who are taking operating system also? I think that we are talking about this in operating system. So operating system nowadays we are using the different device that is solid state disk. Solid state disk SSD is different from here, different from the HDD. It doesn't have the rotation, it doesn't have the moving forward and backward. Using address, we can the randomly access the data like the memory. Okay, it's a non-volatile memory kind of. So we do not use the data even without the power. Okay. However, database we do not use a lot SSD. Why? SSD is faster and there is no latency, but we do not use a lot the SSD in database. Why?
Cost.
cost. It's expensive. Even for your operating system laptop, so roughly $1 $1 per the 1 gigabyte. Why don't we? What if we have the 1 petabyte? Petabyte is 1,000 of gigabyte, 1,000 of 1,000 of 1,000. Okay, it's costly for 1 petabyte. So we still use HDD. Instead, for the specific purpose, we can use the SSD for the database storage. Idea is, so these are the storage of our database. This is physical storage. We don't discuss yet the data structure yet. These are connected to the database. Okay. Do you think how many of them are frequently used? At least one time a day, in general. There is a rule for 20-80 rule. Only 20% of the data are accessed. The other 80% of the data are just history. It's for journaling, okay? Which means we are not going to access or update nor delete such a data, just keep record. And only 20%, less than 20% of the data are inserted and deleted, updated, and accessed, retrieved. So why don't we make this one for the fast the device, like the SSD, and the other HDD. Even some of them are using read-only disk, like the CD-ROM or DVD, much cheaper than the HDD. So these are HDD and these are SSD. Even some of the DBMS nowadays, hot topic is memory-based. This is the solid-state device. It's a memory, but their architecture is similar as a memory, but it's close to the hard disk drive. But why don't we use the real memory? Okay, so volatile memory, much faster. Problem, you may lose data in case the power is down. So by addressing such a problem, some of the very frequently accessed data is loaded into the memory for speed. That is the memory-based database. If you search the Google memory-based database, the architecture and the technology are nowadays hot topic to speed up the database access. So these are the overall idea of how we can use the storage for database. Okay. So this still HDD is the most popular disk storage. Okay. This is the same topic that we discussed. Eventually, we are going to store the data in the sector. There are two types of store the data on hard disk drive. One is using the file system. What is a file system? It's a software. Operating system install the file systems, the software like the NTFS or ext2, 3, or 6, 8, something like that. File system. Then database can use such a file system as the storage. You can use the file as a storage, but different types of the file. Sometimes you can use the TXT file, sometimes you can use the Excel file, sometimes you can use your own file. For example, the Oracle has the extension as the DBF, for example. They're all the file structure. Okay? Another way is raw device. What is a raw device? Raw fish. Without crew. Without using file system, we can directly store the data on the sector. Okay? You should know how to access the sector. Okay? Actually, who is in charge of such a thing? Operating system and device program, controller program. Control program actually know how to access it, how to write the data, how to read the data from the device. But If you borrow that idea to the DBMS directly use such a raw device as a storage. Benefit? Which one will be faster? Raw device is much faster. Okay? You don't have to use the software. Software is, it will be overhead because it's in the in between. So you can directly access the data. Problem? If somebody override this one, it cannot be protected. So you should be careful. So if your system is very critical for the efficiency, so you can use a raw device. Because of that, mostly operating system is in charge of the raw device, accessing the raw device, but this time, most of nowadays commercial DBMS can do such accessing the raw device, which means somebody said DBMS database system is kind of in between application program and operating system, right? Because some of the functionality provided by the operating system move to the DBMS. This is one example. Even process management, memory management, these are the topic of operating system. DBMS can directly manage such a computer resource. For what? Speed up. Speed up is the most important part. Okay, but we are not going to discuss about the raw device, accessing the raw device. It's more like an operating system topic. Okay, so this is actually the same topic that we have learned in the operating system, so you can quickly go over this one. Just like the operating system, to speed up, we can, during the main operation of the hard disk drive and storage is the input and output, right? Read the data and return the data. However, when we read the data, when you search the data, okay? When you read the data, there is a latency. You need to find the exact location of the data, and when you find the location, then read the data and return it. So there is some little bit delayed time, right? While you are searching the location of your data. So why don't we use such the delayed time or latency time by interweaving the two process, two I/O. We are going to support the two I/O. Then we do write the data. While you are searching, the other process can read and write the data. Okay, this is an interleaved fashion to speed up. Okay. Then finally, this is the more like the low level hardware, the data hardware, the configuration. Okay, specification. Then we need to know the data structure, how the file, how the storage are organized. First, database require record. What is a record? Data structure. For what? For file? File consists of one record, two record, one. We have a number of data in our database, right? What is the entity? Entity type is the group of entity. What is a table? What is a relation? It's a group of data. Group of row. What is a table? It's a group of row. So to represent each data, each row, each entity, we need a record in the file. Logically, not physically. So this is logically, the file consists of number of record. Why? Because we need to support the database concept. Group of data. So group of record. Each record has what? Attribute. Okay? So that is the time. Okay? Sometimes the amount, date, and time, and AC. Okay? Then they should be separated. So each attribute should be separate, and each record, mostly record by record. How can you separate? So can you close whatever? Do you need a hat? So thank you. One file, one table. Table will use this file, like the student table. Okay? When you define the student table in the three-schema architecture, it's a conceptual schema, student. Then student will create the one file. Then each file has a number of students, number of records. So each record will be separated by new line character. One line represents one record, one line represents one record. And each line, each record has a number of attributes. Okay? So that is the basic, the logical data structure of the database file. So in other words, when you develop the DBMS, actually the previous one, UVDB, the relational database, used the TXT file. So which means when a user create the student, you saw the creating table. So when a user create the table, create the one student.txt file using Apple. Then whenever user insert the data, create the one record. Another insert is a new line character. Okay? Each operating system, file system has different new line character. Like the Unix and Linux use the /n, and Windows has the line feeder, something like that. So we can use such a thing. And each record has a number of attributes. For example, there are two types of the attribute. One is the fixed. The fixed means just like the variable character and character. As you have been, I think it was the homework, voluntary homework. So you research on the difference between variable character 1 and variable character 2. But I believe that you understand the difference. It's a fixed and this is a variable, same idea. So it was used at the beginning of the database storage, the fixed and the variable length. So this one is from the variable length. Problem? Fixed length, no problem because it's a fixed. The DBMS can read after 30 bytes for the social security number. However, what about the variable length? We need to separate special character, okay, which is not used a lot. Okay, it's only for the separator between the variable, the attribute and other, the next one. Okay.
Professor,
Yes.
for the fixed length, don't we have a problem with fragmentation, internal and external fragmentation?
Fragmentation, yes, it's a kind of internal fragmentation, but because if we have the lead, so the other, it's a waste of space. Okay, even we cannot use that part. Okay, only for updating. So using updating you can use, otherwise there's no way. Even it's not a fragmentation, it's a waste of space.
But let's say that, for example, for one record we separate, I don't know, 50 bits or 50 bytes, and we only use it. We're only using 30, for example. What happened with the other 20?
20 is a waste.
So we're losing space.
Yeah, losing the space.